Hello everyone, thank you for signing into my live stream. I'm Mr. Matt and this is Dr. Tot and Cookie. Very good. And welcome to Pre-Algebra. So we've talked about adding and subtracting whole numbers, and this week we're going to talk about multiplying whole numbers. So multiplication is different than addition. Addition was the combination of groups together, and those groups didn't have any semblance with one another, didn't have any specific inherent relationship between the values. It was just one clump plus another clump equals a bigger clump. Multiplication does increase usually when we're multiplying by numbers greater than 1. However, it increases by a scalar projection, or what's called scalar projections. And so one number times another is that number the other number of times, or is the sum of that number the other number of times. So for example, 2 times 3. 2 times 3 is 2 3 times. So 2 plus 2 plus 2. 2 plus 2 plus 2 is 6, so 2 times 3 is 6. You could also think about that as 3 times 2. That would be 3 2 times, or 3 plus 3, which is also 6. So it's the projection of one value forward by the number of values in the other term. And we can think about that on a number line, which we will do. We're going to do some visualizations just with groups of values, and then also on a number line. But for now, think of addition and multiplication as both increasing values. There's some caveats to that when we get into negative numbers, when we get into numbers between 0 and 1. But for the most part, addition and multiplication are your increasing values. Addition is clumping together, and multiplication is scaling out, projecting out by that number a certain number of chunks dependent on what the other value is. So let me go ahead and share my screen with you, and then we'll get into some problems. So as always, this is a live stream, so there's a little bit of a delay with the smartboard, but otherwise I'll keep track of that. If there's any questions, please let me know at any point. You can ask your question in the live chat feed, or you can drop a comment below in the comment section. So the overarching theme, multiplication is the opposite operation of division. Multiplication represents a projection of one value, or in other words, it is one value added to itself a number of times equal to the second value. So for example, 3 times 4 is 3 4 times, or it's 4 3 times. So 3 plus 3 plus 3 plus 3, that's 12, or 4 plus 4 plus 4, that's also 12. In either case, 3 times 4, or 4 times 3, will give you 12. We could think of some other values here, for example, 2 times 5, and also just some symbolism. Multiplication can be represented a few different ways. We can use a dot, we could use an X, and we can also use parentheses. So notice that all three of these guys are exactly the same thing. To think about this on a number line, let me take a number line up through 10. So notice another way of thinking about this is 2 5 times. If we take 2 to be the individual unit that we're repeating, 2 5 times is going to be 5 2s in a row starting from 0. And if we continue this pattern, notice that 2 5 times ends up at positive 10. Conversely, you could also think about this as 5 2 times. And if we did that, then we'd have larger individual units, individual segments, but fewer of them. 5 2 times would also land us at 10. So in this case, this is 2, plus 2, plus 2, plus 2, plus 2 is 10. In this case, it's 5 plus 5 gives us 10. To represent these as items, for example, with this problem, we could have 2 plus 2, if these are just items, whatever they are. That would give us 10 items. Or conversely, we could think about this as a group of 5 items plus another group of 5 items gives us that same group of 10 items. So however you'd like to visualize it, all of those demonstrations mean the same thing, but addition is the clumping together. Multiplication is a scalar projection, or it's like multiple additions unto itself. Some number added to itself a certain number of times dependent on the other value. 3 times 4 is 3 added to itself 4 times. 2 times 5 is 2 added to itself 5 times. And you can always flip those around because multiplication is commutative, meaning that order doesn't matter. 2 times 3 is 6 in the same way as 3 times 2 is 6. 4 times 3 is 12 in the same way as 3 times 4 is 12. You can flip them around, the result or the outcome will not change. If you have any questions, then please let me know. We also need to go through some vocab. So they're not always going to strictly just say 3 multiplied by 6, even though you will see that. Some other names or words that imply multiplication: product, times, the phrase multiplied by, scaled also implies multiplication. Another one, the preposition of, so 3 of 6 or by, can also imply multiplication. And those come up a lot in word problems, and we'll get some examples of those. Remember, addition and multiplication are commutative, meaning that order does not matter, meaning that you can flip the problem around. So 3 plus 4 is the same thing as 4 plus 3. They're both 7. 3 times 4 is the same thing as 4 times 3. They're both 12. On the other hand, subtraction and division are not commutative, and therefore order does matter, meaning that you cannot flip the problem around and get the same result. Notice that 3 minus 4 is negative 1. 4 minus 3 is positive 1. Those are not the same results. And also, 4 divided by 3, that would be 4/3. 3 divided by 4, that would be 3/4. Those are also not the same numbers. So you can flip multiplication and addition around. You cannot flip division and subtraction around. Okay, I'd like you to look at the following 2 problems. I'm going to give you 2 minutes, and then I'll give you the solution. I'll keep track of the time in the upper right-hand corner, and I'll update it per minute. Okay, so for number 1, 6 times 4. So we can think of that as 6 4 times, 6 added to itself 4 times over. Or we could also think about that as 4 6 times. So I'm going to do the former. So if we have 4 groups of 6, so you could spend the time of counting all of those up, or you could also represent them numerically as just 6 plus 6 plus 6 plus 6. 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24. So 6 times 4 is 24. 8 times 3, that's 8 3 times, so you could graph it, you could visualize it as those dots, but we want to get right to the algebra of it, or the arithmetic I should say, and we could represent this as 8 3 times, so 8 plus 8 plus 8. 8 plus 8 is 16, 16 plus 8 is also 24, so both of these guys equal 24. If you have any questions, then please let me know. Otherwise, I'll give you 2 minutes. Please look at the next 2 problems. Okay, so 5 times 4. So we can think of that as 5 4 times. So that's going to be 5 plus 5 plus 5 plus 5. So 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is going to be 20. 2 times 6. So that's 2 6 times. I'd also want to recognize that that's also the same thing as 6 2 times. 6 plus 6 is 12, so 2 times 6 is 12. If you have any questions, let me know. Otherwise, let's look at the next values. First problem is a little bit of a trick, so I'll just give you a hint, but well worth understanding why. So I'll give you 2 minutes and then I'll give you the answers. So the rule with 0 is that anything times 0 is 0. 0 is the great nullifier when it comes to multiplication. And that might be easier seen if we first think about 1 times a number. 1 times 4, or actually conversely, let me write that as 4 times 1. 4 times 1, that's 4 one time, right? So I put 1, 4, one group of 4 down. Obviously that's equal to 4. Now think of that process in terms of 4 times 0. You would literally put no group down. And so 4 or 7 or 10, anything times 0 is going to be 0. So the answer to the first problem is 0. 0 times 4 is 0. 0 times any value is always going to be 0. For the second value, or second question rather, we have 7 times 4. So we can think about that as 7 4 times. Or we can numerically represent it as just 7 plus 7 plus 7 plus 7. 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. So the answer to the first problem is 0. The answer to the second problem is 28. If you have any questions, please let me know. Otherwise, let's look at the next two problems here. We have 9 times 4 and 6 times 7. I'll give you 2 minutes. Okay, so 9 times 4 is 9 plus itself 4 times. So 9 plus 9 plus 9 plus 9, or it's 4 plus itself 9 times, but let's stick with this. 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. There's a rule with multiplying by 9s less than 100. It's if you have 9 times a number, you subtract 1 from that number, and that's the tens value of the result. And then you subtract that number from 10, and you get the ones result. So notice 9 times 4. 4 minus 1 is 3. That tells me the tens is a 3, as in 30. And then I take 10 minus 4. That's 6, so the answer is 36. If I had 9 times 5, 5 minus 1 is 4, so the tens digit is 4. 10 minus 5 is 5, so the ones digit is 5. So it's a little handy trick with multiplying by 9. The second question, 6 times 7. So I'm going to have 6 7 times. And actually, the 6 times 7, 7 times 8, and 6 times 8 products are among the pretty much the 3 hardest products below 100 to memorize. So if you just memorize those, all the other ones come a lot easier. But 6 times 7 is going to be 42, because 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24, 24 plus 6 is 30, 34, do I not have enough here? Oh, I'm sorry, I'm missing a 6. Oh, I was in trouble there for a second. Starting over, 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24, 24 plus 6 is 30, 30 plus 6 is 36, and 36 plus 6 is 42. If you have any questions, let me know. Otherwise, I'll give you 2 minutes. Please look at 2 times 3 and 6 times 5. Okay, so 2 times 3, that's going to be 2 3 times. 2 plus itself 3 times. 2 plus 2 is 4. 4 plus 2 is 6. 6 times 5, that's going to be 6 plus itself 5 times. So 6 plus 6 plus 6 plus 6 plus 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. And 24 plus 6 is 30. So 2 times 3 is 6, and 6 times 5 is 30. And the last two sets here, let's look at 8 times 4 and 2 times 4. I'll give you 2 minutes, and then we're going to go move on to two-digit numbers. So 8 times 4 is 8 plus itself 4 times. So 8 plus 8 plus 8 plus 8. 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. So the answer to the first problem there is 32. For the second problem, we have 2 times 4. So that's going to be 2 plus itself 4 times. So in other words, 2 plus 2 plus 2 plus 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So 2 times 4 is 8. If you have any questions, then please let me know. Otherwise, let's look at the next set of problems. So we're going to move on to 2-digit values. So with 1-digit values, you can use the simulacrum or the parallel that exists between multiplication and addition, where multiplication is the projection forward of values, so it's one value plus itself a certain number of times for the other value. We can do that with 1-digit values, but that's much harder to do with 2, 3, 4, 5-digit values and so on. So in order to solve those types of problems, it's best to use a vertical orientation, just like with addition and subtraction. So I'm going to show you here how we would do that, and then you're going to have some examples to work with yourself. So I usually like to take the smaller value on the bottom, but it doesn't really matter. But if we have 28 times 12, you just have to match up the ones digit with the other ones digit, tens with tens, hundreds with hundreds, so on and so forth. And what I'm going to do is I'm going to start with the ones digit of 2, and I'm going to multiply it first by the other ones digit. 2 times 8 is 16. I can only write one digit at a time, so I'm going to write the 6 and then regroup above the tens digit because it's 16. It has one 10. Now I'm going to do 2 times 2, which is 4, but I have that regrouped 1, so I have to add 1. So 2 times 2 is 4. 4 plus 1 is 5. Now I'm going to go over to the tens unit. But because the tens unit has a 0 implicitly in it, when I multiply by this number, I have to already place a 0 as a placeholder because I'm multiplying by the tens. So when I move into the tens unit, the tens digit, I have to place a 0 as a place marker in the ones digit because I am assuming that these are multiples of 10. 1 times 8 is 8. Notice that that's not above 10, so I just write 8 and I don't have anything to regroup. 1 times 2 is 2. So now to find the answer, I would add these two together. 6 plus 0 is 6. 5 plus 8 is 13, so write the 3, carry the 1. 1 plus 2 is 3. So 28 times 12 is 336. I'm going to give you 2 minutes. I'd like you to look at question number 2. Okay, so I wanted to write this all out as just some hints there, but I'm going to do this in different colors. So let's look at this. Let me do this in green. So first, 2 times 3. 2 times 3 is 6. 6 is not greater than 10, so I just write the 6 in the 1's value, and then I move on. Let me do this guy in orange. So now, 2 times 9. I have 18, but I don't have any other place to regroup it over. There's no hundredths value in 93, so I just write out 18. 2 times 9 is 18. Now I need to write a placeholder of 0, remember, when I move on to the tens digit. Now I'm going to have 2 times 3. 2 times 3 is 6. Not greater than 10, so that's fine. Just leave that there. And now let's look at this 2 times 9. 2 times 9 is 18. There's no thousands place to regroup, so I just write out the 18. And now I'm going to add them all together to get my final answer. 6 plus 0 is 6. 8 plus 6 is 14. 1 plus 1 is 2. 2 plus 8 is 10. So I keep the 0, carry over the 1. 1 plus 1 is 2. So your answer here is going to be 2046. If you have any questions, then please let me know. Now I'd like you to try these two questions. I'm going to give you 4 minutes, and this pair of questions will bring us up to the end of class today, but we'll pick back up on Wednesday with some more examples. So 4 minutes, please complete questions 3 and 4, please. At about about 2 minutes in, I'll start to set up the problem and solve. Okay, so 24 times 87. If we line those up, and now you could have had 87 on the bottom. I just put the smaller ones usually on the bottom, but it doesn't matter. Turn out to be the same answer as long as you follow the rules correctly. The first digit, 4 times 7 is 28, so we keep the 8, carry over the 2. 4 times 8 is 32, plus the 2 is a 34. So we have 348 on the first line. Then we move over to our tens units but when we do that, make sure that you place in your placeholder of 0. So that's where that 0 comes from. 2 times 7 is 14, so I kept the 4, carried over the 1. 2 times 8 is 16, plus 1 is 17. Adding those together, 8 plus 0 is 8, 4 plus 4 is 8, 3 plus 7 is 10, so I keep the 0, carry the 1 over, and 1 plus 1 is 2088. For the second question, 72 times 80, we have 2 times 0, that's 0. 2 times 8, that's 16. So our first line is 160. Moving on to the tens units, we're going to place our 0 as a placeholder. Then 7 times 0 is going to be 0. 7 times 8 is 56. So adding these two values together, 0 plus 0 is 0, 6 plus 0 is 6, 1 plus 6 is 7, and then there's nothing to go with that 5, so it just remains a 5. So we have 5,760. So as always, if you have any questions, then please let me know. Feel free to drop a comment in the live chat feed or in the comment section below. I'm here for you every Monday, Wednesday, and Friday for pre-algebra. Remember that Tuesdays are reading sessions, and Thursdays are our writing skills sessions. So this was Mr. Matt, and Dr. Tot, do you want to get a cookie? Do you want to earn your cookie, Dr. Tot? You better come over here. I think he fell asleep, but he's got to earn his cookie. Come on. You want to say goodbye to everybody? You guys say goodbye. Bye. Good boy. All right, thank you guys very much for watching. I'll talk to you all on Wednesday.